Good morning. My name is Scott Levitt, and I'm a math instructor at Portland Community College. Chris Hughes, another math instructor formerly at PCC, and I were the two instructors chosen to participate in the accessibility study focused on the math courses we offer at PCC. The entire experience of participating in this project was and continues to be both challenging and very rewarding. Prior to starting the project, Chris and I both had a deep interest in making sure that the content we produced for students was accessible, and we were both familiar with MathML. MathML stands for Math Markup Language, which parallels HTML, standing for Hypertext Markup Language. It was first developed in 1998 and is the encoding used to produce math notation on web pages, in order to capture both the structure and the content of the mathematics. As far as we were concerned, this project seemed like a natural area for us to research, and our pairing was also a natural one as well, given our complementary backgrounds. Chris works on PCs, I work on a Mac. He uses open source products like LaTeX, and I predominantly use Microsoft Office and MathType. As a team, we are both knowledgeable about the majority of the products and platforms used by the math faculty at PCC. Both Chris and I naively went into the project with the expectation that we would find the answer for producing completely accessible mathematical content for our online courses. From the little experience we had with assistive technology, we thought that this single answer would ultimately rely on accessible web pages, combined with MathML, and using JAWS to read the web pages out loud. Based on that premise, we began investigating the products used by the math faculty at PCC to produce content for their courses. For 15 hours a week, for about 3 weeks, we worked in a computer lab, this computer lab in fact, and we looked at the methods we could use to produce accessible web pages with properly formatted mathematical content from these various products. We looked at both proprietary products like Microsoft Word and MathType, and open source products like LibreOffice and LaTeX. We tested these products on both Macs and PCs, and started to learn each product's process and quirks on both systems. About 4 weeks into the project, Kayla introduced us to Maurice Mines, and this meeting became a clear turning point in our project. Maurice has a strong educational and technical background, which fit well with the mathematical side of our project. He is also blind and can read Braille. Kayla had the experience to know that our project was going to greatly benefit from having an end user as an integral part of the team. While Maurice was not the only person we worked with who would need some form of accommodation to take a math course, he was the one we worked with the most and gave us the greatest personal insight into the work we were doing. In one particular meeting about halfway through our project, Maurice had agreed to test drive some of the ideas we'd been working on. It was in this meeting that Chris and I had the greatest aha moment we had in our entire project. As we had assumed that a web page using MathML and JAWS would be the solution, that was naturally one of the ideas Maurice tested for us. After Maurice had tried out the formats we had put out for him, an oral lecture format that used raised line graphs, a web page lecture that used JAWS, a printed Braille lecture, and a lecture read on a refreshable Braille device, Chris and I turned to each other and realized how ridiculous our initial assumption had been. Why would there be one answer to make all mathematical material accessible? And why would a web page read by JAWS have been that answer? Everyone has a different learning style, and every person's disability is unique. There can't be one answer. What were we thinking? It's at this point that we came up with our standalone concept. We looked back at the products we had previously tested and explored additional products as well to see if they could stand alone. We considered a product to stand alone if the content produced using that product could easily be converted into an accessible format. For example, properly formatted Word documents that use third-party product MathType to create the mathematical content can be converted into web pages that use MathML, into printed Braille documents, into enlarged formats, etc. So this product combination, MS Word with MathType, would stand alone. On the other hand, a PowerPoint file with any mathematical content in it is not easily converted into any accessible format, so we would not consider PowerPoint to be a standalone product. We developed an entire list of products that we had tested, and classified each as a yes, no, or maybe. The only maybes were the products created by the publishers, and I'll come back to this in a bit. For products that do not stand alone, we said that a faculty member needs to have an equally effective alternative in place. There are many great products out there that can bring certain concepts to life, but they are not and cannot be made accessible. For those products, we want instructors to first think about how the product helps illustrate the course concept, and then to have an equally effective alternative to help the students who cannot make use of or benefit from the inaccessible product. As stated in the June 2010 Dear Colleague letter, we must ensure that all students receive all the educational benefits provided by the technology in an equally effective and equally integrated manner. At the conclusion of our report, we produced a printed document that summarized our process, our findings, and our recommendations for our fellow math faculty. We presented this at one of the quarterly meetings of math faculty, essentially a big department meeting. Of the 7 recommendations, 4 were fairly non-controversial. These 4 stated that instructors need to keep their source files. Instructors can create graphs and images however they would like, but the images need appropriate alt text. Instructors should try to work a week ahead. And instructors should split longer tests into smaller parts for students who have time extensions on tests. Since these 4 were fairly straightforward, everyone basically nodded their heads. The remaining 3 recommendations we called our potentially prickly recommendations, as we thought they might cause a bit of nervousness with some of our faculty. The final 3 recommendations involve online homework or course management systems, such as WebWork or the publisher-owned systems. As expected, faculty members who rely on the publisher's proprietary systems were nervous about our recommendations. At the time of the report, the only online homework management system that had very few accessibility issues was WebWork. Our first recommendation was to encourage instructors to consider migrating to WebWork, as we had some server space graciously hosted by the University of Oregon. Next, it was and still is our opinion that courses that rely upon inaccessible material should not be created. Existing courses would need time to get cleaned up, but new courses based on these materials should be put on hold until the publishers made their platforms accessible. At the time of our report, no publisher-owned system was accessible to any level that we would consider acceptable. Finally, it was and still is our opinion that the selection of new textbooks must consider how accessible the online content from the publisher is. If we adopt a book that does not have an accessible online component, then it is our opinion that the online content cannot be used unless there is an equally effective alternative in place. In the year and a half since we first presented our report and recommendations, several things have changed. Publishers have been putting forward some notable effort to make their systems accessible. The level to which any online system is accessible is still under investigation, hence the reason the content from the publishers is a maybe for our standalone concept. At PCC, the math faculty have started thinking more about accessibility of what we create, and the products we use in our classes. As we look at new curricular materials, I'm happy to say that one of the first questions ends up being, will this be accessible? That being said, there is also some reluctance in giving up on inaccessible products, because some of these products can help many students. The statement, why can I not use, fill in the name of an inaccessible product, because I might have one student who can't use it, is still heard from time to time. Others have recently voiced concern that some of us are using a liberal interpretation of what equally effective could mean. I will still say that overall we, in the math departments at PCC, have made significant progress in the direction of both being aware of the accessible nature of what we create, as well as thinking about accessibility as we adopt new curricular materials for our courses. Without a doubt, if I had not had the opportunity to participate in this project, I could not have had such a deep and personal connection to the topic. While it would be amazing for all instructors to experience what I did, it is impractical to expect any institution to be able to fund such a project for every faculty member. Giving faculty a chance to explore how different assistive technologies work, JAWS, refreshable braille devices, etc., during in-service meetings, as well as having faculty reading up on the topic of accessibility in mathematics, and there's been a fair amount of articles published in the UK on this topic, all of this will help inform faculty members on some of the challenges faced by students needing various accommodations. Finally, one of the best things to come from our project was our administration's understanding, or acceptance, that WebWork is a system that we should not only encourage, but that we should have on our own servers. This is something that others will follow up with in a few minutes. Thank you for your time.